Okay, ladies and gentlemen, let's talk about angles and parallel lines. Now, anytime we talk about lines, we can talk about them in either 2 dimensions or 4 dimensions. Sorry, 3 dimensions. So in 2 dimensions, we have two lines right here. These two lines are parallel. These two lines would be intersecting. These two lines would be perpendicular, but perpendicular is nothing more than a specific type of intersecting. So intersecting and perpendicular still only have one solution. The other alternative is where we have concurrent lines, and that's where one line is perfectly right on top of another line. So in essence, instead of two lines, you really have one line. But in 3 dimensions, we can have a number of other things. I can still have parallel lines. I can still have intersecting lines where they actually touch. I can have perpendicular lines. I can have one line right on top of each other. So no big deal there. But in 3 dimensions, I can now have what's called skew lines, where they may look as if they're crossing over. But if you rotate the situation, you can clearly see, no, they're not touching at all. So these are skew lines. Now in 2 dimensions, they have to touch. But in 3 dimensions, they don't have to touch at all. So, okay, having covered all of those pieces, let's get down to angles and parallel lines. Now, if I have parallel lines, that means I have two lines that do not touch. All right? I have two lines like this. These lines, even though they don't show touching because they're at different slopes, at different angles, they would indeed at some point touch. Now, regardless, I have two situations. I'm going to do something in each situation, and that is I'm going to cross these two lines, lines L and line M, with another line P. Okay? This line P is called a transversal. Trans because it's going across, verse, okay, because it's not going in any of the same way, so it's not across together, it's across in an opposite or opposing fashion. So we have transversal. I could put a transversal down through these two lines as well. Now, in this case, the transversal isn't quite as meaningful because all of these lines are eventually going to touch. But in this situation, these two lines will never touch, this one will. But what we have is we have a number of angles created. In fact, we have 1, 2, 3, 4, 5, 6, 7, 8 angles created. 1, 2, 3, 4, 5, 6, 7, 8 angles created. Now, by the way, up here you would indeed have 9 and 10 angles, but those are not really what we're up to for today. Now, we have some different types of angles, and they have different names. And so let's talk about a few of these names. We have alternate exterior angles. Alternate exterior angles. Now, ladies and gentlemen, math people are not creative. So let's talk about the various names. If I have the word alternate in it, alternate or alternate, that means they're going to be different or opposites. So for example, 1 and 2 are alternate angles because they're on opposite sides of the transversal. 3 and 4 are alternate angles. 3 and 6, 3 and 8, 3 and 2. All of these are alternate angles because they're on opposite sides of a transversal. Okay, now let's talk about the next word, exterior. Exterior, well, exterior means outside. So in this case, 1, 2, 7, and 8 would be exterior angles because they are outside the parallel lines. Outside, exterior. So that means if we have alternate exterior angles, we could also have alternate interior angles. Alternate, again, opposite. Interior, meaning inside. So now we're talking about 3, 4, 5, and 6 because they are inside. They're inside the parallel lines. Now we also have this one called corresponding. Okay. Corresponding. If I have something that corresponds to something else, it matches up with something else, okay? So if you are playing tackle, okay, on the line in football, you have a corresponding tackle across from you in all likelihood. Now, maybe in a gap, but he's in essence doing the same job on defense as you're doing on offense, or vice versa. Offensive line, defensive line. You have corresponding components. If you're in volleyball, you have blockers up on the front, up by the net, and volleyball on each side. They do, in essence, the same thing. You're corresponding. In this case, corresponding would be 2 and 6. 2 and 6 are corresponding, and here's why. They're both on the same side of the transversal, and they're both on the same side of each parallel line. So this one is top and right. This one is top and right. So they correspond. Now, 3 would also correspond to 7 because they're bottom left, bottom left. Okay, so we have corresponding. So alternate exterior, alternate interior, corresponding. We also, of course, have vertical. There's that guy again, vertical angles. And, of course, vertical angles across the vertices from one another. So 3 and 2 are vertical angles because they're across the vertex from one another. 1 and 4, but not 1 and 8. 1 and 8 might be the same size, but they're not across the same vertex. 8 would go with 5 across the vertex. 7 goes with 6 across the vertex. So we have vertical. So all of these are going to have some special properties. We also have what else is called a same side interior angle. Same side interior angle. So let's think about it. Same sides, they have to be on the same side of the transversal, and they have to be interior, so they have to be inside. So I'm talking about 4 and 6. If I were talking over here, it would be 3 and 5 because they're on the same side, the left side, but they're inside each parallel line. Now, each of these angles may have some special properties with parallel lines, but they exist just as well down here in these lines. Whereas we can guarantee that 1 is congruent to 4 because they're vertical angles. Vertical angles are always, always, always congruent. So vertical angles are congruent every single time. 2 is going to be congruent to 3. 6 is congruent to 7. 5 is congruent to 8. The difference is, in our case, alternate exterior, so opposite sides, 1, 7, and 8. Exterior, 1 and 8 would be alternate exterior angles. Here, 1 and 8 are still alternate exterior angles. But we'll talk about the difference between parallel and not parallel in just a second. So alternate exterior, opposite sides outside. Alternate interior, because they're opposite sides but inside. We have corresponding. 1 is to 5, 3 is to 7, 4 is to 8, 2 is to 6. All those are corresponding. Vertical angles we already talked about, and same side interior, 3 and 5, 4 and 6. Now, those are the names of the angles. Let's go ahead and start talking about some properties. If lines are indeed parallel, so you have to be given line L, line M, given L is, now look what I did here, I used 2 vertical bars. That means parallel to M. If you're given that L is parallel to M, what I can do is I can put little arrows on these 2 lines. Those are the symbols for parallel. The little L's are the symbol for parallel. Now, if I cut this by a transversal, I have some special relationships. 1, 2, 3, 4, 5, 6, 7, 8. I can say 1 is congruent to 4. 1 is congruent to 4, you need to give me a reason. 3 is congruent to 2, you need to give me a reason. 5 is congruent to 8, you need to give me a reason. and 7 is congruent to 6. You need to give me a reason. So 1 to 4, 3 to 2, 5 to 8, 7 to 6. That is what you need to give me a reason for. Now, moving on. Well, by the way, these were vertical angles, and vertical angles. Okay, we also have some other ones. We have angle 1 is congruent to angle 8. Angle 1 is congruent to angle 8. Reason being, these are on the opposite sides of the transversal. They're outside. If lines are parallel, alternate exterior angles are congruent. So if 1 and 8 are congruent, then by extension, angle 7 is congruent to angle, fill in the blank, please, 2 by alternate exterior angles. So we have this is congruent to this. Now, moving on, we have some more. We have angle 3 is congruent to angle 6. Angle 3 is congruent to angle 6. Why in the world would this be congruent to this? Alternate interior angles, which means angle 5 is congruent to angle what? 4 by alternate interior angles. So we have that. Now you'll notice, by the way, look at my symbols. One little arc, two little arcs, two little arcs. One's an arc with a circle, One's an arc with 3 little slashes, arc with 3 little slashes. It doesn't matter, but as long as you put the same symbols in each place, they're showing that they are congruent. Now, so we have vertical angles, alternate exterior angles, alternate interior angles. The next thing we need to talk about is angle 3 and angle 7. What's true about angle 3 and angle 7? Well, they're going to be congruent by what reason? Same side of the transversal, same side of the parallel lines, corresponding. In parallel lines, corresponding angles are indeed congruent, which means now I have angle 1 is congruent to angle 5. So they have by corresponding, C-O-R-R. We also have angle 2 congruent to angle 6 by corresponding. We also have angle 8 and 4. Angle 4 is congruent to angle 8 by, again, corresponding. So we have that. So we have vertical angles, alternate exterior, alternate interior, and corresponding. So those are all good. Now, the last things that we need to talk about is angle 3 and angle 5. What do you think is true about angle 3 and angle 5? I'll tell you now, it is not congruent. What does angle 3 and angle 5 equal? 180 degrees. These two together are going to add up to 180 degrees, and that's from same side interior angles. By the way, they're also called consecutive. All right, consecutive angles. So 3 and 5 are consecutive. 4 and 6 would also add up to 180 because they are also SSI or consecutive, okay? So the thing is, alternate interior, all these exist regardless of whether the lines are parallel or not. But if the lines happen to be parallel, then all of these things are true. Now, obviously, given something is true, you can prove all the others over here, and that's what we're going to be headed into next.